We go back to chapter 5 to discuss files. We covered loops before. Today we would like to start talking about files. And when we say talking about files, is how to read from a file, how to write to a file, and how to add information to an already existing file. So imagine the following scenario. You go and collect data from an experiment, or let's say collect data from users. And what you do is that you have, let's say 1,000 entries of data. All right, whatever the format is. Okay, it could be a single information like age for 1,000 people and try to find the average. It could be a full information. It could be like populating an object of a user, which could be names, age, address, social security, phone number, whatever that object is. You collect all of these data. So let's just keep it as simple as the age of 1,000 people. That's the simplest form you could think about. Ideally, what you want to do is that you have a .java file, all right, a code that you created, which is going to process the information, right, and gives you the output, which is the average age. All right, something like that. Very, very simple. Now the problem is, how can you get these 1,000 entries to this Java process or Java program? Now, what we have done so far in this course is that we learned how to use a keyboard, right? So we learned how to use a keyboard to enter data to a program. Now the thing is, getting this 1,000 information through a keyboard, that's gonna be painful. All right, and imagine what happens if you enter one of them wrong. Correct? How can you say no? I don't want this one. How can you, like, today you enter all the 1,000 and then for some reason you would like to add one more, so you go in the next day and you re-enter all of these inputs through the keyboard. That's a lot. That's very time consuming and a waste of time. Now, one other way to do this is to actually put this in a file, like a text file, for example, and then have a direct link that goes from this file to the .java code, right? So in this case, what you are really doing is that you are reading from the file, right? And then you output the average. So in this case, you don't need this one. So in general, if you think about it, many times you find that you need information or inputs from other sources, right? And that's why we say this is the standard input, right? But that doesn't mean it's the only input. You could read from a file. You could read from a whatever sensor that is, right? You could set it in a way that it just feeds that program directly. All right, so you have many ways of inputs. One of them is the standard, which is the keyboard, right? And the others are non-standard, but they are useful in case you have data size that is impractical to input through the keyboard. The same goes to the output, by the way. You output to the what? To the screen, right? So you have here, this is output to the screen. You have something like here, and then you write here, right? So that is standard output, right? Which is the monitor or the screen of the computer. But you could output to different things. You could output to another file, right? So that's output.text, for example. You could output to let's say a robot, right? All right, so you could control the arm of a robot, for example, right? That's an output. So you are that in that form, that is called actuation. So actuator output, you have sensor input, you have text input, text output, you have the standard input, the keyboard, the standard output is the screen, right? So this is all we the things that we can think about as input and output. Maybe there are others, but for now, this is what we will stick to. So we covered this, we covered this. What we want to do now or today is to cover this one here and this one here. So let's start with this process, write to a file. How can we write to a file? Now, to write to a file, what you want to do is, and you need to think about it this way, you need first to open the file, right? Then write, and then close. All right, so these are the three steps. Open the file, prepare it to be written to, write to the file, all right, and then close the file. Now, for now, I will tell you that it's very important to follow these three steps. The first two make perfect sense because this is what we are trying to do. We are trying to write to a file, so nobody's going to confuse this. But what happens is that people sometimes forget this one, closing the file. So for now, I'm telling you it's very important. Just trust me in that. By the end of this video, I'm going to show you why it's very important, all right? And what happens if you don't close the file. Now, in general, you can deal with files as binary files, right? It will be a file that once you open, you will find a stream of binary characters, zeros and ones. Or it could be text, the files that we usually deal with, and its simplest format is the text, right? Other formats, more complex a little bit, is like doc, docx, and so on. So we will focus on the text, very simple text format for the files. We are not going to discuss binary data for now. Now, how can we write? How can we open the file? The first step is to open the file and prepare it to be written to, all right? So this process is done by telling Java that I would like to write to a file with this name. All right, what happens that when you say that is that Java is going to go create the file if it's not already there, open it, prepare it to be written to. If it's already there, it's going to open it, prepare it to be written to. So that's what happens. Now, to write to a file, we will need an object that will help us to do this. There is an object specialized in writing to files. This object is of type PrintWriter. So that's a new class that we are dealing with, PrintWriter. From its name, it's PrintWriter. It's printing and writing, right? It's a writer for printing information to a file. Now, if you look at the PrintWriter and how it's used, or how it's the constructor of a PrintWriter object, you will find that it's PrintWriter parentheses, and it takes an argument which is a string. And that argument, if you look at it, it's, for example, student data.text, which from it we can see that this is the name of the file where we want to write our information. So again, the general format, PrintWriter, call it whatever you want, output file, student data file, whatever you want, and then say new PrintWriter and pass the name of the file as an argument. Now, there is a great flexibility here that student data.text could be hard-coded this way, all right? So you write it, or it could be stored in a file name string, and then this file name is passed as an input here or argument, all right? It could even be that file name is actually coming from something like this. So for example, here is string, all right, file name is equal to let's say keyboard dot next line, something like this, all right? And then in that case, that file name could go here as whatever the user is going to input, right? So that's just very flexible. You could be any variable could be passed, or reference variable for a string could be passed as an argument to the PrintWriter. All right, so now one last note here is that if the file already exists, it will be erased and replaced with a new file. This here, what is really happening is that the contents of the file are going to be erased, all right? And the file actually is not going to be replaced. We will see this in the file. All right, so PrintWriter, it allows you to write data to a file using the regular printing methods that we know of. So we can use print, we can use println, and we can also use printf. All right, so all these methods can be used before we use it to write to the standard output, the screen. Now we can actually use it to write to a file through the PrintWriter object. So this is the power of PrintWriter object. It allows us to use these methods with files. All right. So notice here that to do this now, put it all of it together, we are creating a PrintWriter object called output file, which is linking to names.txt. Then once this is open, I'm using the PrintWriter object that I created here to print line 3 names, Chris, Catherine, and Jean. And then what I do is that I go and close that object using the close method, which takes no inputs, it just goes and closes this one. So 3 steps: open a file and prepare it to be written to, which is done with this step. We are creating an object which will go and open the file called names.txt and get it ready to be written to. Then using print, print line, printf statements, we go and write whatever we want, and then we go and close the file. So if you put this together in a code, so if we go to Java here, write to file. All right, now I'm going to delete these and just show you the plain structure that we have here. All right, so here, compile. Now, a couple of things. The first thing is that this is what we just had in the slides: PrintWriter, output file, names.txt, and then writing 3 names using printf, print line, and print, for example, here, just to mix things, and then close the file. Now, it will complain that it doesn't know what PrintWriter is, so this means we need to import this. And PrintWriter, since it has to do with input and output, it's actually stored in the input IO package. So in this case, import java.util and utility package, and it's the input output package, right? And then we are PrintWriter here. All right, so that import in this case here, and it doesn't complain about PrintWriter anymore. Now, the other thing it's going to complain about is that there is a possibility, since you are dealing with files now, there is a possibility that the file does not exist, right? Couple of things, scenarios that could go wrong. The file doesn't exist, but at the same time, I cannot create the file, right? Let's say, for example, you are not, you don't have an admin permission, you cannot access this directory, or you don't have the permission to create a file or write to. So in this case, Java will not be able to complete this task, right? So in this case, what it's really saying here is that there is a possibility that I couldn't find file not found exception, right? But you are not dealing with this. Now, to understand what does that mean, it means that something could go wrong and I don't know how to deal with. This is what the code is telling you, all right? Or the compiler is telling you. Now, in that description that I just said is actually the definition of an error, right? I cannot write to a file, error, stop. Now, the thing is, Java has 2 types of things here. There is the error that actually crashes the code and it completely stops. And there is something called exception, which is something that could go wrong, but if you handle it, you will be able to keep the code going. All right, so let's think of it like in a it's a graceful way to deal with an error. All right, so in this scenario here, what it says that it could go wrong, but I don't know how to deal with it. Now, for any code in Java, any method in Java, it has one of 2 ways to deal with this. Either try to handle that exception itself, all right, it takes care of it, or if it doesn't know how to do that, it throws it to the one above it to deal with it. All right, so you can either deal with the exception, all right, and we say here that I could throw an exception and I could catch an exception. So in this case, you can either catch the exception and deal with it, or you could throw it to a person who's more or an entity that is bigger than you, it's going to just deal with it and take care of it for you. In this case here, so for this course, we are just going to deal with throwing exceptions. All right, we are going to throw it and make someone else take care of it. To do this, what you need to do is that you say main method is going to throw, or able to throw, input output exceptions. All right, so it can throw input output exception. Now the input output exception is actually on its own an object. All right, and that's why now it says I don't know what input output exception is. So you need to go here, all right, and you need to import Java from input output, the input output exception. All right, now compile. Now it compiles. So Java now is happy. Now since you are importing two classes from the input output, you could actually replace all of this with the wildcard and import everything in the input output, import the whole package, and that's gonna work and take care of this. All right, so these are two possible ways to do it. All right, so PrintWriter, we create the object, link it to names the text, try to write 3 names in there. Notice here printf with, I could do something like this, right, for a new line, and then print line and then print, right? Or we could, let's make this print and this print line just to see how it's working here. All right, so compile. Now before I compile and run it, I want to show you, here is our file, the folder where the codes are. And notice here that the only text file that I have is the README, which is generated by BlueJ. Now, once I compile this one and run it, notice what's going to happen to the folder. Names.txt was created. It was created at 2:02, which is right now, and it's all the text extension. Now, if I open names.txt, this is what we see. Cress is written. Catherine is written with print, no new line, so it prints with the space after the space Jean, and then I close the file, which is going to take care of it. All right, so that is how you write to a file, and this is why we need the input output import statement and the throws input output exception point. All right, so again, this is what I just explained. When something unexpected happens in Java program, an exception is thrown. An exception as a signal indicating that the program cannot continue until the unexpected event has been dealt with. Like, for example, I cannot find the file, I cannot write to the directory or the file that you are specifying. Disk is full, I cannot create that new file, and so on. So a method that is executing will need either to handle, as we said, right? So you either want to handle or to pass it up the line, so other part of the code or other method will take care of it. And this is what we are doing in this code. All right. So here it just shows that here this is how you throw an exception from the main method for the input output, because we are dealing with files. All right. If you want to read more, this is a link that discusses PrintWriter class and how to interact with. Now, the question is, why should we close the file? So before we finish this video, we need to answer this question. Why do we need to close the file? Now, to answer this, we need to have some kind of a visualization of what really happens when we try to write a file. So in a computer system, there are several memory levels. The first one would be inside the processor. So if you look at the processor here, that's a processor, and inside the processor there are very few and small units of memory. All right, they are countable, they are very, very few, and these are called registers. All right, so they are locations that are holding the information as the processor is adding numbers, subtracting numbers. So you have number X, number Y, I would like to add these together. So X is stored in one of the registers, the Y is stored in one of the registers, and then the process is performed. Now, I need to figure out how to stop rotating this. So now this one here, if you think about it in terms of the amount of memory units, the price, and the speed. All right. So if you think about it here, I'm going to give it, for example, let's say levels. All right, numbers. 5 is the highest, 1 is the smallest. So here, in terms of the amount, this is 1. It's the slowest. All right. In terms of the price, this is 5. The speed, it's 5. This is the fastest and the most expensive memory unit that you can think about in a computer memory hierarchy. All right, and the amount is very few, and that's the reason why it's very expensive, right? It's something that you cannot go and add to. Then there is the cache memory. Cache memory is something closer to the processor. It's not in the process, like it's not part, or it could be inside the processor, but it's not as fast or as few as the registers. So you have the cache memory, all right. So that is there. It's very fast. So I would give, for example, the amount would be 2, the price would be 4, and the speed would be 4. All right. So that's a cache memory. Then comes the let's say the main memory. You have the RAM, all right, which is a bigger location that can hold the applications and things that the processor need, and it's holding it closer to the processor, right? It's not as good as being inside the processor, of course, like registers, but that's the price, right? It's big. So that's why we need to have it outside, but we put it on the motherboard very close to the processor, so this way the processor can interact with it. All right, so that would be in terms of amounts, it's 3, for example. You go and buy 32, 64 gigs of RAM. The price is cheaper, relatively cheaper, and the speed would be less, for example. Then comes, let's say, hard disk drive. All right, so that is the hard disk drive. All right, it could be magnetic or solid state. So that would be the amount. You would have 4 of these, right? Like level 4. The price, it's way cheaper than the RAMs and the cache. The speed would be also slower, even though the solid state may be faster than magnetic, but at the end, it's this level of memory is still slow compared to the RAM, cache, and registers. Then if you continue, you will find, like, for archiving, for example, you could have magnetic tapes, right? We don't see that anymore, but that is still there, all right? Magnetic tapes. The nice thing is that they stay for a long time. They are not mechanical, like as the hard disk, so less probability of losing information. Amount, that's maximum. You can buy a lot of these for very cheap price, and they are very slow, and that's why it's long-term memory that you can store and leave it there. Now, the reason why we are saying all of this is because how is the writing process interacting with all of this? All right, now notice here that if you think about it, the writing is coming from the CPU. So the CPU here is trying to write to a file on the hard disk. All right, so you have your file here, and you are trying to write here names.txt, for example. All right, now notice here that this is very fast, this is very slow, or relatively slow. Now, to match the speed between these two, what will happen is that you cannot speed this up, of course, but you can slow this down. So the fast processor will need to slow down to write to the file properly. Now, that's a waste of the power and the purpose of the processor, right? You want the processor, and every year you go and upgrade and try to buy, or every couple of years you try to buy something more powerful, faster, and can process more information quickly. So that solution is not good. You cannot slow this down to match the speed of a file. So what you do instead is that you put some kind of a buffer. A buffer is like an interface, something that is going to match the speeds. All right. So a buffer is an entity in the memory, and let's say it's in the RAM. And what it does that it takes the information in from the processor at a fast rate. Then it stores this information here, right? And then slowly write to the file at the hard disk. All right, so this means the processor can throw this information, that buffer, quickly, very fast, and doesn't worry about it. And then that buffer, all right, data buffer, is going to take its time to interface and interact with this slow file. All right, now, as the information is stored here to be written, back to the main point why we started all of this illustration is that when you close the file, when you send the dot close or call the dot close method, all right, what is happening is that it asks this buffer to flush all the information stored in it to be written in the names.txt, the file, and then close this link safely after you close this one. All right, so that's the task of the buffer. Now, if you don't do this process, if you do not close, what will happen is that this link is destroyed. You are not writing anymore, right? Because this is not receiving any more information, so it doesn't know what's going on, right? And then whatever information you have here, it will remain here and it will never be written to that file. And that's why it's essential that you close the file after you finish writing, right? Because it sends all of this remaining information in the buffer. It tells it, okay, I'm done writing, we are done, close everything and wrap up. So it goes and takes all of the information, put it in the file, and then safely close that file. So that's why we need to do this. I'm going to delete names, and then what I'm going to do is to comment the close signal here, or the method, compile, write. It's not going to complain. It's going to create names.txt. You open it, it's empty, nothing in there, even though you wrote these three. Now, because this information is very few, you have just 3 lines. It's so few that to the point that the buffer didn't even have to get pushed and write to that file. And that's why all of this information is still in the buffer waiting to be written to the file, which never happens because all of a sudden you close or you stop writing without telling the buffer that you need to go and write this information there. So that's why it's very important to close. Now, one thing that I would like to show you is that, and I hope it's going to work in this case, is that I'm going to try and write this in a loop. Int I is equal to 0, I is less than, let's say, 100, and I plus plus, yep, that's a semicolon. And let's see here without closing. Let's try to write all of this. All right, and I'm not gonna close and try to write to names. And oops, there we go. All right, and let's open names. Not enough. All right. Here we go. So even though I did not close, all right, I tried to write so much information there, and what happens is that the buffer gets full and it starts to write. All right, so when the buffer gets packed, it will start to automatically push out to the file, so it gets more space to write or to store the information coming from the CPU. All right, so this writing here, it's incomplete. It's not going to write. So if I, for example, here actually let's do something like this. Output file dot print, and I'm going to write, or actually we could do it here. I plus. All right. All right. So here, if we scroll all the way down, you will find that we wrote um, 9,494 out of the 10,000. All right, so this is when the buffer got very full and it started to write to the file anyway, so it starts to take more information coming from the CPU. So it's not proper writing, so do not get tricked with the fact that something was written to the file. It's not the full information. It's not because the operation is working properly. It's just because the buffer is getting full. It's trying to write to the file, but it's not writing everything that you want it to write.